Hello everyone, welcome to the 13th tutorial session of the Network Analysis course, whose instructor Professor Tapas Kumar Bhattacharya sir from IT Kharagpur. So in this tutorial session, we will see the few of the problems which we have already discussed during the previous tutorial sessions. This is related to the what we have actually uh, been covered in the previous tutorial session and also which could be helped to solve the problems in the examinations. We will give you the glimpse of the what kind of question could be asked and also we will see the revision portion of it. Okay. So the first problem here, it is being related to the network analysis. So basic network analysis. So if you see the question, it is saying that 10-volt battery with an internal resistance of 1 ohm is connected across a non-linear load whose VI characteristic is given by the 7I is equal to V square plus 2V. It is asking that what is the current being delivered by the battery. Okay. Take few minutes to solve that. After that, we will give the solution for it. Okay, let me give the solution for this. If you see in the problem, it is saying that there is a 10-volt battery. So let me draw it first. Okay, take it this. Suppose there is a 10-volt battery, which is being said that it is a kind of uh, 10-volt battery with an internal impedance or resistance, you can say 1 ohm, and then it is connected to a non-linear load. Suppose this is a non-linear load which is connected across it. and it's a VI character. It means that current dependency of the voltage or the current on the voltage, it is already being given. So relation, it is already given that 7I is equal to V square plus 2V. Okay. So if you ask that how to solve this kind of problems, means when the non-linear loads are given. So if you see the 10-volt battery, it is DC source and 1 ohm resistor which is connected here, internal resistance, and its VI characteristic is given. It means that the voltage which will appear across it, suppose this is positive and this is negative. So V voltage here is appearing. So the one equation is already given, that is 7I is equal to V square plus 2V. So this is first equation. Second equation we need because there is a two unknowns. Okay. So if you through the KVL equation, when you apply the KVL in this loop, it will be simply it will come out to be minus 10 plus, suppose the I current is moving like this, I current is flowing like this. So the minus 10 plus minus drop will be like this, minus 10 plus I times of R plus V will be equal to 0. Or you can say that V is equal to 10 minus I. So this is the second equation. Okay. Now the requirement is that how solving for these two equations. Okay. And then put the value which of V from equation 2 to equation 1. 2 to equation 1. You will get 7 times of I is equal to 10 minus I square plus 2 times of 10 minus I. Okay. When you solve this, let's solve it. 7 times of I is equal to, okay, 100 plus I square minus 20 times of I plus 20 minus 2I. Okay. So the overall it will become 7I square 20 minus 2, it will be minus 22, and here it is minus 29. Okay, 22 7 times of I plus 120 will be equal to 0. Let's solve it by the quadratic equation. See what is the correct value it is coming. Fifth, 1 minus 29, 120. Okay. So the I values are coming as 24 amps and 5 amps. Okay. Let's see which values is actually correct. When you see that what is the value of voltage? Voltage is V is equal to 10 minus I. Okay. So if the I is equal to 5 amps, if I is equal to 5 amps, V will come out to be 5 volt. And if I is equal to 24 amps, the V will come out to be 10 minus I. 10 minus I means minus 14 volt. Okay. But in the question, it is already being said it is a load. Okay. It will take the current. Okay. It will not deliver. It is not a kind of source. Okay. If it is a kind of load, it means that it will deliver. It will consume. Okay. So the minus 14 will not come into picture. Okay. Because here it is already being that in the positive terminal current will enter. Okay. So the 5 amps will be the correct answer because it's a kind of load and it absorbs the current. Okay. The voltage positive terminal will be such that the current will enter the positive terminal. Okay. That's why the current which we consider is as a 5 amps. Okay. So this is the correct answer. Let's move forward and see the second problem. If you feel any doubt in this, just let me know. Any doubt in this? These kind of problems should be solved because one equation will be already given that this is a non-linear load, and one equation will be such that V and I relation will be given. Then the second equation could be founded from the network itself. Okay, by the KVL or the KCL equation, you can solve the both equation and you will get the answer. Okay, let's move to the second problem. Try to solve this. We'll go by the basics and then we will see the variety of the problems which could be which can be asked in the exam basically. You can write the answer in the chat box or you can open your mic and you can tell also, that is fine. Okay, let me give the solution. Okay. So because this kind of problem could be easy to solve because one theorem is being applied in this that is called as the Wheatstone bridge concept. Wheatstone bridge concept. Okay. So in that it will be saying that suppose this is a R1 and this is R2, this is R3 and this is R4 and one internal impedance which is connected between the this R1 and R2, one node of the R1 and R2 in between and the one node in between the R2 and R4, this node, okay, C and D basically. So what the Wheatstone bridge says, concept says that if R1 by R2 is equal to R3 by R4, then the current which is flowing to that network or to that branch which is connected between the node of the R1 and R3 or and the R2 and R4 will be zero. It means that the current which will flow here, this I current, will be equal to zero. Okay, if this criteria will be followed. Okay, so the current which is flowing towards the 2 kilo ohm resistor will be equal to zero. Okay, so try to see also that if any theorem can be applied, if any concept could be applied, so that it can be easy to solve. Okay, because it's a minute bounded code problems. Okay, four options will be there. You have to select one. Okay, sometimes also it could be having the that you have to write some value. Okay, in that check whether any concept or any theorem could be applicable. Okay, it will be easy to solve then. Let's move forward. Try to solve this. Take time and think over it and also try to solve.
Inductors.
Inductor, that's true, but what is its value? L value, if you can find it out. Check that.
1 Henry.
1 Henry. Okay. Inductor and 1 Henry. Okay, let me see whether it is correct or not. Okay. So the circuit element, if I say there is a I and V curves are given, okay, then three elements could be possible in these scenarios, that it could be a R, it could be a C, or it could be L. Okay, the three element it could be possible. And if it is standard equation, because the voltage equation in terms of the resistor or the current which is being delivered in that. So suppose V is equal to IR. Okay, this is standard equation for the R. For C, it is I is equal to C dV by dt. Okay, this will be applicable everywhere. And the third will be equal to voltage is equal to L di by dt. Okay, or you can say for the here also I is equal to V by R. That is same manner. And also you can say that ki 1 by C minus infinity to T and I dt. Okay. Here in the inductor also you can say that I is equal to 1 by L V times of dt. So minus infinity to T. Okay. So these are the standard equation for any elements, whether it is a R, C or the L. By observing the graphs, okay, you can say that which relation is actually applicable in certain bounded regions. Suppose I am considering 0 to 3. Suppose I am taking that time in between 0 to 3 second. Okay. In that scenario, if you see here, the what is the value of the current? Current IT is equal to, what is the slope here? Slope will be the 1. Okay, 3 by 3, y by x. Okay. So the tan theta y by x, that is equal to the 1. So it is a mx kind of graph. So it is equal to t because the slope is 1. Okay. So for what is the value of vt? Vt is a constant. Constant what value? 3. Okay. So it means that which relation is actually applicable here? I is equal to V by R? No, not possible, because it should be in the terms of time. Okay. So
Sir,
yeah.
how I of t is t, sir?
Okay. So if you see here, what is the equation of the y is equal to mx curve? Okay. If you see the y is equal to mx curve, okay, because this is a straight line which is passing through the origin. So that standard equation will be the y is equal to mx. Standard equation is y is equal to mx plus c, but it is passing through the origin. So that's why the c will be 0. Okay. So what is y here? Y is the current. Current is I is equal to, what is slope? Slope is equal to tan theta is equal to y by x. So what is the y by x? It's a 3 ampere here and 3 second here. So the slope will be the 1. And what is the t? X, x is simply t. So that's why the I is equal to t. Okay, that's why we have got from the linear equation, a linear equation basically, the straight line equation of the line. Okay. And similarly, the Vt also, it is seen that it is a constant. It's a 3 volt. So that's why we have kept it as a 3. Okay. So which relation is actually falling into the place? Okay. Suppose I'm considering as a capacitor. Okay. So the I is equal to C dV by dt should be applicable. Okay. Vt is given 3. So it means that the dV by dt will become 0. So the current will be 0. So this is not applicable here. Okay. Current is not zero. What about the inductor? If I consider it as an inductor, so the voltage should be equal to L times of di by dt. Okay. So here the voltage is coming 3 is equal to L. Di by dt is also coming 1. Okay. That's why it means that it's a equation that is equal to the voltage equal to L di by dt is actually applicable here. And the L is equal to 3 Henry. Okay. Because why? Because the voltage is currently as a constant, and also I which you got when you differentiate it, you also will get a constant. Okay, that's why the constant, both are at the constant level, but certain factor multiplied. That is the self-inductance of that circuit. Okay, any doubt in this? If you feel any doubt, just let me know in between. Okay, so that we can move forward and we can do a, good kind of analysis to the problem so that can be easy to solve during the exams. Okay. Let's move forward. Okay. Try to solve this problem. These are the previous problems which we have seen in the tutorial sessions before, but I have kept for a revision purpose. Okay. Try to solve this. Okay. If you are facing doubt, just let me know. Okay. I will make sure that you should get the method to solve. Okay. Okay, let me give the glimpse of that. It's a very easy problem. Okay, in the whatever the manner I have taught in the previous tutorial session, it will be easy to solve. Okay, when you see this kind of circuits, okay, and it is asked that you have what is the value of the time constant. So in this problem, it is asked what is the value of the time constant. Okay, then in this problem, always consider the circuit at t is equal to 0 plus. Okay, t is equal to 0 plus when it is saying that it is being closed or it is being opened. Okay, So here if you see heat is being closed after t is equal to 0 plus. That's why I'm considering the circuit like this. Okay, this circuit will look like something like this. This will be R, this will be 2R, and this will be C. Okay. Now the second part is that you have to see the Thevenin resistance across the element which is given. Okay, other than the resistor. Okay. Suppose it's a given that key capacitor is there. Okay. Suppose this is a capacitor across this. Okay. Now you have to find it out what is the equivalent Thevenin resistance across this C. Okay. For finding out this, you have to short circuit the voltage source. Here the voltage source is given. You have to short circuit it. Okay. If it is a suppose the voltage source is there, you have to replace with the internal impedance, but it is not given, so you have to just short circuit it. The current sources replace it with the internal impedance, but it is not given, so it's just a open circuit. Okay. Here the voltage source is given. For Thevenin impedance to find it out, we just replace the voltage source with the short circuit or the current source with the open circuit. So here we have sorted. Okay. What is the value of here? R, and here this is the 2R, and we have to find out equivalent RTH across C. Okay. So these R and the 2 are in the parallel. Okay. So the what will be the RTH will come out to be R multiplied by 2R divided by R plus 2R. Means when the resistances are in the parallel, it will be equivalent will be R1 R2 divided by R1 plus R2. And it will come out to be 2 by 3 times of R. Okay. If you able to find out the value of the RTS, now the next step is the tau. Tau is the time constant. It will be simply equal to RTSC if it is a capacitor. Okay. Now what will be come out to be? It will be 2 by 3 times of R multiplied by C. Okay. 0.67 kind of. But here the exact answer is not matching. So it's a all options are wrong. That is a 2 by 3 RC. Okay. Suppose I'm saying that that is similar question, but here the inductor is there. Okay, in place of the R is C, there is a L. Okay, in this situation, the tau will be equal to L divided by RTH. Okay, if you're able to find out the value of the RTH, then simply take it as a L by RTH. It will be simply equal to the time constant. Okay. So the what is the first step? First step is the make the circuit at t is equal to 0 plus. Then find the equivalent Thevenin resistance across the element. Suppose the L is there, C is there. So replace C and from that port itself try to find out the value of the RTH or RTH. Then you will be able to, if it is a C element is there, the time constant will be R equivalent multiplied by C. If it is an inductor, the time constant will be L divided by R Thevenin. Okay. Any doubt in this? This is a standard method to solve this problem. Okay, for finding out the value of the time constant. So answer will be equal to 2 by 3 times of RC. Okay. So this is important concept, and this is also important when you don't know anything and the options are given. Okay. Through the time constant also you can judge the answers. Okay. Suppose in the answer time constant is given 2t, e to the power minus 2t or e to the power minus 3t is there. Okay. So it's a basically that key you have to check the what is the value of t. So it is simply t by tau. Okay. Tau here in the e to the power minus 3 tau is 1 by 3 and e to the power minus 2t tau is 1 by 2. Okay. So from this value you can judge whether what is the element, whether it is correct or not, options are correct or not. Okay, let's move forward and try to see a different kind of problem, which is also an important concept. Try to solve this. Try to solve this problem. In this problem, it is given that the initial capacitor voltage, it means that VC at a t is equal to 0 minus is equal to 0. Okay. And the switch is closed at t is equal to 0. The final steady state value of the voltage across the capacitor you have to find out. Okay. Try to solve and just let me know which options are actually correct. And then after that, I will give the final solution and also how to solve it. Solve it. I'm coming in the 2 minutes. Okay. Try to solve and just let me know in the.
Option A, sir.
Okay, let me give the solution for this. Okay, so option A. Okay, okay, let's see how to solve this problem. Okay, so in the previous tutorial session, what I have told that there are standard equation if it is a linear circuits are there and there is a only one energy storing devices are there. Okay, if there is only one energy element is there, energy storing or energy delivering element are there. Suppose C and L, only one element, either C or either L, or register could be any value. Then the standard equation of Vc capacitor will be equal to Vc 0 minus plus Vc infinity minus Vc 0 minus e to the power minus t by tau. Okay. If capacitor, only one capacitor is there, no L. Okay. If only one inductor is there, in that situation, the current value of the inductor will be equal to ILT is equal to any time of any particular time, IC0 minus plus IL infinity minus IL 0 minus e to the power minus t by tau. Okay. Tau, we have seen that how to find out the time constant in the previous problem itself. Okay. Now here the thing is what is the value of Vc0 minus and Vc infinity or ILT, because here the C is there. So the equation which that will be applicable here is the Vct is equal to Vc0 minus plus Vc infinity minus Vc0 minus and e to the power minus t by tau. Okay. So what is the value of Vc0 minus? Vc0 minus means when the circuit, when the switch is being not being closed, okay? When it was there in the open circuit situation, it was already given that Vc0 minus is 0, okay? Then how to find out the value of Vc infinity under the steady state operation, okay? Under the steady state operation, the capacitor will be always assume capacitor as a open circuited. Okay. Suppose what is the value of IL infinity if it is an inductor? Then assume the inductor as short circuit. Okay. So because it will be get saturated under the steady state situation so that it cannot hold the more number of charges what is there initially. Okay. So it got saturated. It reached to its maximum limit. That's why it got open circuited. Open circuit means it cannot hold the voltage which is higher than that, which is being applied across. Okay. That's why if you open circuit the capacitor here in this circuit, suppose in this circuit, if I redraw, it will be simply like this. Suppose this is the 20 volt and this is the 10 ohm and this capacitor will be open circuit and this is the 10 ohm. Okay. So the voltage which will appear across this open circuited terminal, what it be? It will be simply equal to current. What will the current will flow? Current is equal to 20 divided by 21 ampere. Okay, so the 1 ampere will flow here to here, 1 ampere. So what is the voltage across this? It will be equal to 10 volt. Okay, so the 10 volt will appear here. Okay, so the simply VC infinity will become 10. So what will be the equation of the VCT? VCT will be equal to VC infinity. VC infinity is G10 because VC 0 minus is 0, e to the power minus t by tau. What is the value of tau here? Tau is, let's find out the value of tau. Let's take another slide, new slide here. To the with the concept which I have told. So the the voltage will simply like this, 20 volt, and the switch was like this, and there is a one resistor, then capacitor, and then one resistor here. Okay, this is also 10 ohm, this is also 10 ohm, and this C was given 10 microfarad. Okay, so the how to find out the value of time constant? Time constant means consider the circuit at t equal to 0 plus. It means that it is closed here. Now the second point is that you have to short circuit the voltage source. Let's short circuit it and then remove the capacitor. Remove the capacitor, the circuit will look like something like this. Will be simply like this, 10 ohm here, 10 ohm here. Okay. Seeing from this points A, B, this 10 ohm and 10 ohm will be in the parallel. Okay. So the RTH will come out to be 10 multiplied by 10 divided by 20. Okay. So it will come out to be 5 ohms. What will be the time constant? It is simply RTH C. So RTH is 5 multiplied by C, 10 microfarad. Okay. That's 50 microfarad basically. So the 10 is there, no? So the 10, 10 and 10 microfarad is there. So it's the time constant is 50 microfarad. Okay. Not here. You should they if you see that whether it is in the parallel or the in the series. So if you see from the A and B port, 10 ohm and 10 ohm they are in the parallel. So that's why the equivalent R will come out to be 5. Okay. So you can put the value of the tau here that is equal to 50 microfarad and then you will get the all the equation of the VCT. You can find any of the problem like this. Suppose it is being asked that at t is equal to 2 seconds, what is the value of the voltage across the capacitor? Okay, just put the value of t is equal to 2 in this equation. If it is asked that what is the value of current, then differentiate is because I is equal to C dV by dt. Differentiate this voltage VCT multiplied by C and then you will be able to find out the current which is flowing across the capacitor. Okay. So in this question, it is asked that what is the final steady state voltage? Steady state voltage means make a capacitor open circuit and find out the value of VC infinity. It's actually coming at the 10 volt. So the option A is correct. Okay. Any doubt in this? Remember this is standard equation. It is very important to solve the most of the problem. Okay. Any doubt in this? Okay. Let's if you able to solve it or understand this problem, try to solve this. Okay. The similar way, try to solve this problem. Use the standard equation ILT is equal to I0 minus plus I infinity minus I0 e to the power minus t by tau, because there is a one energy element here, either L or either C. If it is a L, use this equation. Try to solve this.
Sir,
Yeah. Yes, you wanted to ask something?
sir, in that equation, I into I at t equal to infinity will come as sir.
I t is equal to infinity. Can you repeat, please, again? Can you repeat what you have said?
Is the equation correct, sir?
Yeah.
In previous class, you said I at infinity plus I at 0 minus I at infinity is into e power minus t by times.
In the previous problem. Okay. Tr- I will give the solution for this. Then after that, I will take that question. Okay. Then it will be easy to understand for you. Okay. 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 Let me explain the problem first. Okay. In this problem, it is saying that there is a one series RL circuit is there. That is the resistor is there and inductor is there. Okay. And is excited at t is equal to 0. Excited at t is equal to 0 means this voltage source will come into the picture only after t is equal to 0. It means that this switch is being closed at t is equal to 0. Okay. And then it is saying that to assume the initial conditions to be 0. It means that the I 0 minus is equal to 0. There is no flux which is being stored inside of the inductor. Okay. And it is asking that what is the value of d square I by dt square at t is equal to 0 plus. Okay. In this kind of problem, it is very easy when you use these equations. Okay. Let's go step by step. Let's find out the first the tau, the time constant. What is the value of time constant? Time constant, I have told that if it is an inductive circuit, it will be L divided by RTH. Okay. When you're able to find out the this time t is equal to 0 plus, this switch will be closed, and then this voltage you have to short circuit. So if you short circuit this voltage source, this will be simply R and this will be simply L. Okay. Now find the equivalent R across the L. It will be simply RTH is simply equal to R. So that's why the tau is simply L by R. Okay. And also, what is the value of this is the first point here. Important. The second point is that I is equal to 0 minus. It is already given that 0. What is the value of I infinity? I infinity is that you have to, if it is single valued inductor is there, single inductor is there, or single capacitor is there, just if it is a capacitor, the steady state voltage you have to find out by open circuiting the capacitor. If it is an inductor, just short circuit it. Okay, capacitor open circuit, inductor short circuit. When you short circuit, the equivalent circuit look like something like this. This is R, and this here it is a short circuit. Okay, so this was the inductor which was short circuited, and this is V. So what is the current it will flow? It is simply equal to V by R. Okay, so what is the standard equation will look like? ILT is equal to I0 minus, it is already 0. What is the value of I infinity? Simply V by R e to the power minus t by tau. What is the value of tau? Tau is, let's take tau here, tau itself, and here the tau is equal to L by R. Okay, if you're able to solve this, okay, let's give the glimpse of okay, what is the question actually it is being asked. Okay, so the ILT we were able to find it out like this: V by R e to the power minus t by tau, and tau is simply equal to L by R. In the question, it is asked that what is the value of d square I by dt square at t is equal to 0 plus. Okay, that I is simply the current which is flowing through the inductor itself. That is simply equal to ILT only. Okay, let's differentiate the ILT. Let's differentiate ILT by dt. It will come out to be V by R minus 1 by tau e to the power minus t by tau. Let's differentiate it again because it is asked that double derivative of the I. Let's differentiate. It will come out to be V by R minus 1 by tau initially minus 1 by tau e to the power minus t by tau. Overall, it will come out to be V divided by tau square. What is the tau here? L by R. Put it in the equation. It will come out to be R multiplied here tau square, which is equal to R square L square by L square, and e to the power minus t by tau. It will be simply equal to V R divided by L square e to the power minus t by tau. And it is being asked that at t is equal to 0 plus, put the value of t is equal to 0 plus, you will get d square ILT by dt square at t is equal to 0 plus is equal to VR by L square. Which option is actually matching? Okay, minus VR by L square. It is actually matching with the D, but why it is coming negative? V by R e to the power minus tau. Okay, okay, is equal to V by R. That's true. V by R. Mhm. Check it by yourself that it is actually coming out to be VR by L square. Okay, maybe some differentiation problem. Have you got the glimpse of this problem? That what is being asked? It is asked that what is the double derivative of the current which is flowing across the inductor? Okay, if you be able to find out the value of the ILT, basically at generalized equation that at a what if at a particular time t, what could be the standard equation? Then you will be able to find out solve try to able to solve this kind of problem. That what is the double derivative of that? Okay. Any doubt in this? Yeah. What was your problem? You can now discuss. Okay. And
No, sir, I got it.
okay, that's fine. So in this kind of problem, if there is a one inductor on the one capacitor is given, use these methods. Okay, you will be able to solve any kind of problem. Okay, let's move forward and try to solve this. Okay, use the same concept here. It is here in the question, it is saying there is a one voltage waveform, it is a time dependent, and it is equation is given 12 t square. Okay, and this voltage waveform, suppose this is a voltage waveform, it is being applied to a inductor whose L is 1 Henry and initial current through it is 0. It means that IL 0 minus is given as 0. It is being asked that what is the value of the current at t is equal to 0, t greater than 0. Okay, try to find it out. Okay, Vt is equal to 12 t square. What is the value of current IL at t greater than 0? Let me know which option is correct.
So if t greater than 0 also we should use that equation, sir.
No, here there is a one also catch there in that equation which I have told. That equation is applicable when the only one energy element is there, either L or either C. And the second important point there is that the source should be linear. Source should be linear means if it is a standard means voltage source, it should follow that voltage source. Suppose it could be a constant DC source or it is a AC source, not a kind of a time dependent source. Okay, so it's a non-linear source here. So that formula is not applicable in this. Okay, okay, getting my point. So the source should be linear
Yes,
and
sir.
the okay. Now try to solve this. 24T, I got the one answer as option B. Okay. Okay, let's wait for a few more seconds. After that, I will give the solution and re-verify whether it is correct or not.
Option D, sir.
Okay, option D. I got one more option. Okay, let's see the what could be the possible solution for this. So the standard voltage equation of an inductor is voltage is equal to L di by dt in terms of current. Okay, and it is asked that what is the value of current? I will be equal to simply 1 by L V dt. Okay, now here the integration term came. Okay, it means that if you have the t square, you will integrate, you will get t cube. Okay, so from that perspective, you can say that option D is correct. Okay, let's try to solve it. Okay, through that also you can just. Okay, let's solve. 1 upon L, L is given 1. What is the value of voltage? It's given at 12 t square dt. Okay, minus infinity to t, I. But it is also given that the initial current through it is 0. It means that the integration will move from 0 plus to t. Okay. because at the 0 it is 0. Okay, 12t square dt. When you solve it, it will come out to be 12 t cube by 3. It will come out to be 4t cube. From 0 to t, it will be simply equal to 4t cube. So the correct answer will be option D. Okay, got the point? Use that equation itself. Okay, so that's why it is very important that you should mentally present at that point of time. Okay, it means that the current voltage equation is L di by dt. So the current will be integration of the V. So V is 12t square, integration, it became cube. Okay, let's move forward. Let's try to solve this problem from whatever the concept I have given. Here you can see that there is a not single C, single capacitor is there, but you can apply here the that concept of the time constant because you can do and make a equivalent of this capacitor. Okay, you can make a C equivalent out of this. Okay, so after that you will get one single C and then the resistor, that is the 3 ohm, this is the 3 ohm, and this is the 3 ampere. Okay, now you can apply that equations. Okay, in some of the problem it is already given that key there is a not only one source, multiple source, but you can make equivalent out of that. Okay, try to solve this.
Option D, sir.
Option D. Okay, let's wait for few more seconds, re-verify whether it is correct or not. Okay, option C I've got. Okay, let's see whether it is correct or not. Okay, so what is the value of C equivalent? Let's find out the first the value of the C equivalent. C equivalent is that like this. Okay, one capacitor here, 1 farad, one capacitor here, 1 farad, and one capacitor here. Okay, this is also 1 farad. Okay, so these two are in the parallel. Parallel means it will get added up simply, so it will become simply 2 farad. Now here there is a 1 farad. Okay, so now the C equivalent will be, if they are in the series, you can add like this. Okay, equivalent will be 2 farad multiplied by 1 divided by 2 plus 1. That is 2 by 3 farad. Okay, so now the thing is, C equivalent you have got that 2 by 3 farad. Now important point is that how to find out the value of the RTH. RTH I have already told, if there is a one is if there is a current source, you will do the open circuit. Okay, if you open circuit it, this circuit will not come into the picture, and you will find out from here that RTH, this 3 ohm will come in series, that is simply 6 ohm. So the RTH R equivalent will come out to be 6 ohm. Now, how to find out the value of tau? Tau will be simply equal to RTH multiplied by C equivalent. What is our value of RTS? That is 6 multiplied by what is the value of C equivalent? That is 2 by 3. It will come out to be 4 seconds. Okay. Important point here is that when you are using the capacitors or seeing the means registers, try to verify that whether it is coming in the series or whether it is coming in the parallel. When you removed this, when you have removed this point, this part here, so it became simply like this. This circuit will come into the picture. Okay. And from seeing from the capacitor side, when you see from the capacitor side, this to 3 ohm will be in the parallel series basically. You have to add it. It will be 6 ohm. Okay. Any doubt? So the correct answer will be the 4 second.
Sir, if impedance is parallel, we should use Z1, Z2 by Z1 plus Z2.
That's true. That's true. When the impedances are in the parallel, you will be used that if suppose two impedances, suppose this is the two resistors are in the parallel, you will use simply equation R1 R2 divided by R1 plus R2. But when they are in the series, okay, they simply will be equal to summation of that R1 plus R2 by R plus R3. But if it is a capacitor, then it becomes reverse. If capacitors are in the parallel, you will add it. When they are in the series, you will just use in the parallel fashion. Means opposite of the resistor, you can use the formula for the capacitor. Okay, got my point?
Yes, sir.
Okay, let's move forward and see the few AC analysis circuits problem. Okay, try to solve this. There is a one resistor is there whose value is 17.32 ohm, and there is a one inductor is there whose value is J10 ohm. It is being asked that what is the phase angle of VL with respect to VS. Okay, try it. Okay, 30 degrees. Okay, let's wait for a few more minutes and re-verify whether your answer is correct or not.
Sir. 90, sir.
Okay, I got one more answer as 90 degree. Okay, let's check whether which option is correct. Okay, so when you have this two impedances, suppose this is Z1 and this is Z2, and there is a one source connected here. This is the V1, which is voltage drop across Z1, and this is the voltage drop across Z2. So by the voltage division principle, V1 will be equal to Vs times of Z1 divided by Z1 plus Z2, and V2 will be equal to Vs Z2 divided by Z1 plus Z2. Okay. So by same principle, what is the value of VL? VL will be equal to Vs multiplied by J10 divided by 17.32 plus J10. Okay. Let's assume that Vs is at a angle 0 degree. Okay, but you have to take one as a reference, so that's why you will be able to find out for the other one. Okay, let's solve it. What value it is coming? Okay, I'm taking calci 17.32 plus 10 times of I. Take 17.32 It's 10 times of, okay, 10.32 plus 10 times of I, 10 times of I divided by S square. It is coming out to be, it is coming out to be zero point 0.5 angle. What angle you are getting? Anybody? Complex 2. Angle it is coming 60 degree. Okay. So if you take the Vs as a reference, suppose I'm taking Vs as the angle of 0 degree. Okay. So its value of the VL will come out to be 60 degree leading. So this will be 60 degree and its magnitude will be the zero point 0.5 times of Vs. Okay. Getting my point? So the VL will be actually leading the Vs by 60 degree. Okay. So it's a easy kind of problem, but you have to use the concept. Okay. If the Vs is already given, suppose the Vs is given, it is being asked that what is the phase angle of one with respect to other. Let's take one angle as a 0 degree. Okay. Then find out the value of the VL with respect to Vs. Then you will be able to find out the value angle by which it is leading or lagging. So here, this is the VL, which is equal to zero point 0.5 times of Vs, whose magnitude is coming, and it's leading Vs by 60 degree. Okay. Any doubt in this? So the correct answer is 60 degree. Any doubt in this? Okay. Okay, then let's move forward. Okay. Try to solve this problem. Let me zoom it further. Try to solve this problem. So it means that there is a one node. Node, when you say it's a only two elements, okay? Means greater than two elements or equal to. But junction is the more than two element. Node can be two, but junction is more than two. So here the three branches are there. Suppose this is I1, this is I2, and this is I3. So here it is saying that mark entering into the node. So this is a, suppose this is a node A. So the all currents are actually entering the node. Then you have to tell that if it is a I1 and I2 are given, what is the value of I3? Okay, try to solve it.
Sir, I have doubt in previous problems.
Yes, yes, tell me what is the doubt.
So calculator is not allowed muscles. So by using the to convert 10J into polar form,
See,
root a
yeah,
square plus b
that's true.
square.
That's true that if it a calculator is not there, I don't know whether calculator is allowed or not. But if it is not allowed, then the problem will be set like this, that only, which can be solved easily without a calculator. Okay, don't worry about that.
So we can use that formula also to convert root
Yeah,
a
yeah,
square plus b square.
yeah, you can use that. You can use that, you can convert here root 10 square plus 17.32 of square. Angle will be simply tan inverse 10 divided by 17.32. Okay,
So we should convert 0 plus 10J into polar form and denominator into polar form.
it's not required basically. Okay, So you can convert 10J. Suppose this is a, let me give you a glimpse. 10J divided by 17.32 plus J10 is there. Okay. This is simply a 10 angle 90 degree here. And here what is the magnitude? It will be simply 10 square plus 17.32 of square. What will be the angle? Simply tan inverse divided by 10 divided by 17.32. So the overall magnitude will come out to be 10 divided by 10 square plus 17.32 of square, and angle will be 90 degree minus tan inverse 10 divided by 17.32. Getting my point? And also there is a important point there
So
is
if
that, yeah, yeah, tell me.
0 plus 10 Germans, you can write directly 10 angle 90.
Yeah, yeah, that's true. Because the 10 is already the magnitude and J is already given, so its angle is a 90 degree. Okay, you can directly write it.
For
Yeah. If you are having any doubt, just let me.
is there any shortcut like that for some any other numbers? So if 10 Germans, you can write 1090. Is there some other like that?
Yeah, there is a no means trick for finding out the this kind of uh, uh, values and all. Okay, but there is a one catch here. Okay, when you're writing a plus jb into the form of a square plus b square angle tan inverse b by a, you have to see the coordinate. Okay, that is more important. If you are having a simply suppose 2 plus 3j all positive, it will come out to be in the first quadrant. You can use this formula. But if it is like this, minus 2 plus 3j, then you have to use, there's a different thing here, that you have to use root a square plus b square. Magnitude will be same, but angle will be equal to 90 degree plus, or you can say that 1 tan inverse b by a 90 minus, or simply you can say that 180 degree minus. Okay, this I have explained in the one of the tutorial session. You have to see the coordinates. Suppose here minus a plus jb is there, so the angle will be equal to 180 degree minus tan inverse b by a. Okay, if it is in the third quadrant, then the angle will be simply equal to minus 180 degree plus tan inverse b by a. Okay, if it is in the fourth quadrant, it is simply tan inverse b by a. You can see that lecture where I have explained. In the third or fourth tutorial session, I have explained this. Okay, in the more detail by taking a question itself. Okay, so there is a no
In
trick that,
first and fourth quadrant, same value comes.
yeah, some value will come, but the negative sign will be there. That is tan inverse b by a in the first, fourth quadrant, it will be minus tan inverse b by a. Okay,
Yes, sir.
okay, try to solve this problem. Try to solve this problem. Uh, uh, So in the exam, the given calculator will have inverse tan or not. I don't know yet. Uh, because I'm actually not aware of the exam process. I'm just my job here to give you a glimpse of the tutorial sessions, which will be help you to solve the assignments. Okay, let me give the solution for this. It is asked that if the I1 and this I2 equations are given, what is the value of I3? Okay, remember this. There is a one trick to solve this problem. Remember this coordinate which I am giving. This is sine, this is minus sine, this is cos, this is minus cos. Okay, what is the meaning of this? It means that suppose I1 is given as minus 6 sine omega t. So what is the magnitude here? It's 6, but it's a minus sine omega t. Okay, it means that the minus sine omega t, where this line is the minus sine omega t. Okay, so the magnitude is 6. Okay, 6 million. Second thing is that I2 is given. I2 is given as 8 cos omega t. Okay, which is the cos omega t term value equation? This is the cos omega t when it is a positive. So it will come here 8. Okay, so it is asking that what's the value of I3? I3 will be equal to, because when you say that it's entering, it means that the I3 plus I1 plus I2, its summation will be equal to 0. Summation of I will be equal to 0 at a particular node. So the I3 will be equal to minus times of I1 plus I2. Okay. When you use the rectangular formula to find out the what is the value of I1 plus I2, that's a just equivalent. Okay. So what is the angle here? It will be simply equal to tan inverse 8 by 6. 8 by 6 means because this is 8 and this is 6. Okay. So let's find out what is the value it is coming. Tan inverse 8 by 6. 8, 8 divided by 6. Tan inverse of answer. It is coming. This is coming 53.1 degree. Okay. Yeah, that's true. 53.13. And what is the magnitude equivalent? It is coming 64 plus 36 means 10. Okay. But it is coming something like this. When you write it, so this is a minus sign omega minus sign. Okay. And it's a leading by 53.16. The equivalent will be 10 minus sine anti-clockwise omega t plus 53.13. But the answer will be minus of that. Minus of that will be means it will come like here. So it will be simply equal to tan sine omega t plus 53.13. Let me explain it again. Okay. Let me let me again solve this so it will be easy for you. Okay. What I am saying that draw like this coordinates. This is sine. Remember this. This is sine. This is minus sine. This is cos, and this is minus cos. Okay. So the I1 is the minus 6 sine omega t. It means that it will lie in this line, simply equal to minus 6. So it's come out to be here 6. Okay. Second, it is saying that ki 8 cos omega t. Okay. So this will be minus cos here, no? So 8 cos omega t. So 8 will come like this here. So this magnitude is 8. Okay. Now, when you find out the using the rectangular formula, the equivalent net will be coming here. Its value is 10. And this angle is coming my 53.13. Okay. This I3 minus I3 basically. So when you wanted to find out this value, how to write this 10? From minus sign, it actually in the anti-clockwise direction, it is 53.13 degree. So equivalent when you write, it will come out to be 10 minus sine omega t, because this is minus sine omega t plus 53.13. Getting my point? Because it was leading with the 53.13, that 10 angle. Okay. But it is negative of that, so it will come out to be in the opposite direction, so it became plus 10. Suppose I didn't got like this, I got something like this. Suppose this was some uh, uh, 6 here and I have got 8 here. Okay, the net will be something like this. So this is the cos. So when you write this 10, it will come out to be 10 cos omega t plus whatever the angle it is. Suppose this is theta, so that it is leading with this cos omega t with theta. Okay, it is easier to solve this kind of problem with this concept. Okay, any doubt in this? Any doubt in this? Okay, let me give you one question out of this. Okay, similar to based upon this concept, let me give you one question and try to solve it. Okay, here itself. Suppose this I1, it is simply equal to minus 6 sine omega t, and I2 is equal to 8 cos omega t, which is already given. In the question is that find the angle at which I2 is leading or lagging I1. Okay. So for this kind of question, it will become easy to solve by this method. So this is sine, this is minus sine, this is cos, this is minus cos. How to represent I1? I1 is simply equal to minus 6 cos sine omega t. So I1 will come here. I1. I2 is 8 cos omega t. So I2 will come here. Okay. So if you see that this is the angle of 90 degree in anti-clockwise direction, it means that I2 is leading I1 by 90 degree. Getting my point?
Cos should come up, minus cos should come down, I see.
So suppose that it is minus cos here, minus 8 cos omega t. So then it will go in opposite
No, sir,
direction.
in the graph,
In the graph,
in the graphs.
yeah, the minus cos is upper in the opposite direction of the cos.
Okay, sir.
Yeah. Suppose the question is like this, minus 8 cos omega t. Minus 8 cos omega t means I2 will come here. Here it will be the I2. Okay. Now now I1 is leading I2 by 90 degree. Getting my point? So the leading and lagging you can easily find out by this methodology. Okay? Any doubt in this?
No, sir.
Okay. So this concept is very, very important and it will make you solve the problems very easily. Okay? Let's move forward. Try to solve this. Okay, let me solve this. Okay, so this is not a very difficult problem. Okay, listen here. So I'm giving you some glimpse here. You wanted to say something?
Option D, sir.
Okay, option D. Okay, so let's see whether it is correct or not. So it is saying that there is a one impedance whose value is 4 minus J3 ohms, and the current which is flowing into that is 5 cos 100 pi t plus 100. Okay, so there is a concept that ki S is equal to P plus JQ. Q is the reactive power and P is the real power and S is the apparent power. Okay, so the reactive power which will be consumed in L or delivered by the C must depend upon the lagging and leading, and the real power is absorbed in the R only. Okay, so the power will come out to be simply I RMS square by R, because the loss will is represented in terms of the RMS, and it will happen across the R only. Okay, so what will be the IRMS? IRMS is 5 divided by root 2, because 5 is the maximum value. So the RMS is 5 divided by root 2. Its square multiplied by R, it is given 4. So it will be simply equal to 25 divided by 2 multiplied by 4. Okay, it will come out to be 50 watt. Okay, any doubt? Because the
Yes, sir.
the power loss will be simply happen across the R, that is simply equal to I RMS square. if it is asked, suppose in the question it is asked that what is the value of Q. So for finding out the value of Q, it will be simply equal to I RMS square multiplied by X, which is given. So what will be the value? I RMS. I RMS is given 5 by root 2 of a square. What is the value of X? It is 3. Okay, this is R plus JX form. Okay, so it will come out to be 25 divided by 2 multiplied by 3. It will come out to be 75 by 2 or 37.5 kVA. kVA. Okay.
So if average power is real power.
Yeah, register will means dissipate the real power only, not the reactive power. Reactive power is being absorbed by the inductor, means lagging reactive power will be absorbed by the reactor, and lagging reactive power will be delivered by the capacitor. Okay.
Yes, sir.
Okay, let's move forward. Try to solve this problem.
Option B, sir.
Option B, 1 by root 2. Okay. Let's wait for a few more seconds. After that, I will give the solution. Option B. Okay. Okay, let's solve it. Okay. So in this type of problem, you have to take one reference. Suppose I am taking this as a reference. Okay. And this is the node A. Let's apply the KCL at the node A. So at node A, I always assume that the current is leaving that node. Okay. So, but IT here it is actually coming into the node. So I've taken minus I plus. Suppose the voltage across this is V. Suppose I'm taking this is as a V. So it will be V divided by 1 plus V divided by what will be the value of this? This is simply equal to J1 because the J axle minus J divided by omega C. Omega here is 1 because sine omega t. So omega is already 1. J omega L minus J divided by omega C. So it will come out to be 1. So if you see that this is J minus J equal to 0. Okay. So the equivalent impedance will come out to be 0 here. Okay. And this is the shortest resistance path. Okay. And this 1 ohm will get sorted. Why? Because there is a 0 impedance which is appearing in the parallel of that. So the current will flow simply from one source to from here to here. Okay. So the 1 ohm will not come in picture. Equivalent will look like this. This is the source and this will get short circuited and the 15 ohm 1 ohm will not come into the picture. So simply it will be like this. So IT will be like this. And this is the 1 ohm. This is 1 sin t. So the what is the value of IT? IT is simply equal to voltage divided by impedance, that is sin t divided by 1. Okay, that is sin t. So what is the RMS value? RMS is maximum divided by root 2. What is the maximum here? 1. 1 divided by root 2. So the option B is actually correct. Okay. Any doubt in this?
No, sir.
Okay, let's move forward and try to solve one equivalent impedance kind of. Suppose try to solve this. Find out the value of Thevenin voltage across AB. If you're facing difficulty, just let me know. Okay. Okay, let me give the solution. Okay, because you will be having the limited amount of time while solving the problems in the exam itself. So you should practice more before going for exam. Okay. So this is a problem we have already taken in the one of the tutorial session. Okay. So for Thevenin equivalent, if you see the Thevenin equivalent, it simply look like this. So this is the VTH and the one series impedance that is come out to be ZTH. Okay. Suppose this AB. Okay. For Thevenin impedance, this is very easy. That wherever you wanted to find out the Thevenin equivalent, just short circuit the voltage source and open circuit the current source. Okay. For VTH, basically, you don't have to do anything. Just you have to take that circuit and find out the voltage across the AB. Okay. That terminal itself. Okay. AB terminal it is being asked, so you have to find out. If you see this circuit here, you can convert this circuit into the equivalent voltage source. So by converting this circuit into the equivalent source, it will come out to be like this. This positive, where the pointer is actually means direction it is moving, consider it as a positive. Opposite side consider it as negative. Okay, this. So the V is equal to simply I times of R. What is value of I? I is 6 here and R is 5. So it will come out to be 30 volt. What is the value of equivalent R here? That is simply the resistance what was there in the current source. So if the current source with a parallel resistance, you can convert into the voltage source with that series impedance. Okay. Now if you see it become like this 10 ohm. This is the terminal A. This is terminal B here. And here this is 10 ohm. And this is also 10 ohm. And there is a voltage source here that is 16 volt. Okay. When you apply the KCL here, if you apply the KCL, suppose I wanted to apply the KCL here at this particular node and by making this ground, I assume that this is voltage V. When you apply, it will be V minus 30 because I am assuming current is leaving that node divided by 5 plus V divided by current because the current across this plus V minus 16 divided by 10 is equal to 0.
So V plus 13 by 10 should 15 should be 10 ohm resistance.
No, 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 no. Because here the 5 ohm resistor is there. If you see the 6 ampere and 5 ohm is in the they are in the parallel, so that's why here it is 5 ohm. So here 10 ohm, here 10 ohm that was initial, and this is the oh that's true. Here it will come out to 15. That's true. Okay. So it will be 15 ohm. That's true. So let's take the LCM. LCM, let's take 30. So it will come out to be 2V plus 30 means it will come out to be 60 plus 3 times of V plus 3 times of V minus 48 is equal to 0. When you solve, it will come out to be 368. 8V is equal to plus 48 minus 60, or 8V is equal to 10, 82541 minus. So the V will come out to be minus 12 by 8, or 423, or minus 1.5. Okay, so the option A will be the correct answer. Okay, any doubt in this kind of problem? Don't take more amount of time. Try to solve a few of the problems so that the concept became clear in your head. You don't have to just means think of okay, what could be done here. Try to solve as many as problems so that it could be easy and you can be seen from the first go and you will be able to solve it. Okay. Any doubt in this?
So we can write as
Yours?
16 minus 10 by
I'm not getting what you're saying. Can you repeat it?
we can apply loop KVL in it. That is
Yeah,
16-volt loop. That's it.
yes, you can apply. You can apply this KVL
By
in this
using
loop.
KVL,
Yes, you can apply the KVL also. You can apply the KCL also, depending upon what comes in your mind first. Okay, you can use any of the method, but which method is easy and faster, it will come by the practice only.
sir, I used the potential dividing method, sir,
No, you cannot apply the
for the
potential.
16.
No, no, no. You cannot apply the potential difference here. Voltage division principle here. Because the problem is that there is a 16 source connected here and the 30-volt source connected here. You cannot apply the voltage division principle in this. In the previous tutorial sessions, if you remember, I have given you that where you can apply the voltage division principle. If it is a resistors are there in the series, you can apply. But if the resistors with a series with series voltage source is there, you cannot apply the voltage division principle there. Okay, you already have asked that problem there, but you cannot apply here the voltage division principle here, because whatever the current, suppose I'm taking that some current is flowing from here, it will go from here, but it will get divided because there is a two parallel circuits are there. You cannot apply the same current which is flowing here. So voltage division principle is like this, that case same current is flowing to the both the circuits. But here it is not the case. Here suppose the I is flowing, so here I dash will flow. Getting my point? Okay,
But potential is same as
yeah,
V equal
no,
to
no, no.
16 into.
No, 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 no. Potential is not same. So let me show you why it is not same. Let me take this. Suppose in the problem itself that this is a 16 volt, this is the 10 ohm, this is the 10 ohm, and also here's one circuit is there. Okay. Suppose I'm saying that ki current I is flowing here from here. I. Okay. What from your perspective, what you are saying that you are assuming like this. This is the 10 ohm, this is the 10 ohm, this is the 10 ohm, this is the 10 ohm. So the potential will come out to be same here. That is not the case. Okay. So the current will flow here, I. Here it becomes I dash. And this current will be flow I minus I dash. Okay. So the voltage will be simply, suppose this is 16 volt. When you apply the KVL here, it will be 16 equal to 10 times of I dash plus 10 times of I. Okay. But if the this circuit is not there, suppose I'm considering that this is not there. So it is simply like this. This will be 10 ohm. This is 10 ohm. This is 16 ohm, 16 volt. In this case, the 16 will be equal to, suppose I current is flowing, 16 is equal to 10 times of I plus 10 times of I because same current will flow here. Now the potential you can say that this is both are equal. Okay, but in the previous it is not there because it's the 10 I dash, not the same current will flow into the series. Getting my point?
So if current is same only we should use voltage divider for this.
Yeah, the voltage division principle is only applicable when there is a impedances are there and there is a no current which is flowing out of that current. Apply where the series is there, series impedance. Suppose I take one example here. Let me take one example here. Suppose there is a one voltage source here V and there is a one resistances are there. This is R1 and this is R2. Okay. Now you can apply the voltage division principle there. That is the V, which is voltage across the R1 will be equal to V multiplied by R1 divided by R1 plus R2. And the V R2 is equal to simply V times of R2 divided by R2 R1 plus R2. But if it is like this, suppose this is voltage V and there is a one R1 here and this is R2 here and there is a one more circuit with a voltage source here and there is a series impedance. You cannot apply the voltage division principle across the R1 and R2. This is simply for this circuit only. Getting my point? If the voltages are connected across the R1 and
Yes.
R2, then you can apply. Okay? Okay, let's move forward. I will take the two more problems, uh, giving the glimpse of the two-port network first. Then I will give the for the op-amp circuit. I will solve. Just you have to see how I'm actually solving. For the two-port network, important point is that you should know the matrices. Matrices means what I'm saying V1, V2 is equal to Z11, Z12, Z21, Z22 times of I1 and I2. For all the matrices, whether it is Z, whether it is Y, whether it is H, whether it is T, whether it is G. Remember the matrices for all these two-port networks. Okay, two-port parameters. Okay, it makes you easy to solve this problem, these kind of problems. And after that, make KCL or KVL and make the equations. Okay, suppose for this problem, if you see the current which is flowing here is the I1, and from here the current which is flowing is the I2. Okay, the current which is flowing here is the I1 plus I2. Okay, when you apply the KVL in this loop, the first equation, when you applying the KVL in this loop, it will come out to be V1 is equal to I1 plus I2 times of Z1. Let's apply the KVL in the other loop, this loop. It will be equal to V2 is equal to I2 times of Z2 plus I1 plus I2 times of Z1. Okay, it will simply will be equal to I1 times of Z1 plus I2 times of Z1 plus Z2. This is simply can be written as V1 V2 is equal to Z1 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 plus Z2 times of I1 and I2. You just have to make the equations in whatever parameter it is being asked. Okay. So the answer will come out to be option D. Okay. Remember the matrix, make the use the KVL or the KCL, make the equations, try to fit it when whatever is being asked, then try to solve it. Okay. Any doubt in this? That is a very easy problems for the two ports network. Just remember the matrices. Okay. I will take one more problem of the op-amp. Okay. So in these problems, I have already told you that try to take one means whatever is being asked, try to use the virtual ground concept. Means the current which will enter the positive terminal is always zero, and also the current entering the negative terminal is always zero if the op amp is said as it's ideal. In the questions, you will get only the ideal circuits, not in the details, non-ideal circuit. That is a different concept. Okay. So when you say that here it is zero, here it is zero, so whatever voltage coming here, it will simply will be reflected to the other negative terminal, the node which is connected towards the negative. Suppose I am considering this is a V. So the same voltage will appear across this node. Suppose this is A, this is B. So the voltage at A will be simply equal to voltage at B will be equal to the V. Okay. Apply the KVL. Suppose I am considering here the one loop here. This is the one loop. Apply it will simply will be like this. So this is V1, this is 1 ohm, and this is the 4 ohm, and this is V2, and this is V. Okay. So what is the current will flow? Current will flow simply equal to V1 minus V2 divided by 5. Okay. So what is the value of voltage V? Voltage V will be equal to V2 plus current which is flowing multiplied by 4 ohm, because from this side what I am taking, from this side what the current, so it will be simply equal to V2 plus current which is flowing toward the 4 ohm. It will be simply equal to V2 plus I V1 minus V2 divided by 5 times of 4. Now apply the KVL in the other loop at the other node. Suppose at node B I wanted to apply the KCL. So it will be equal to V minus V3 divided by 1 ohm plus V minus V output divided by 9 ohm is equal to 0. Now I have got the second equation. This was the first equation. So whatever the unknowns are there, what is being asked? It is asked that V output. So this is the unknowns V. But you know from the first equation that this is the value of the V in terms of the V1 and V2. Put the value of V here. You will get the V output as a function of V1, V2 and V3. Okay. Op-amp problems will come simple, very simple. Just use the virtual ground concept. No current will flow into the positive side, no current will flow into the negative terminal. Use the same voltage which is connected nearby negative voltage equal to the node voltage which is connected at the positive side. You put the KVL and KCL, you will get the answer. Okay. Any doubt in this? If you don't have any doubt, so that's all for the today's session. So this is the end of this whole tutorial session. This was a quite bit of important topics which is being covered for the network analysis. I hope I have cleared few of the doubts of yours. So that's all from my side. So this is the end of the tutorial sessions. Okay. Thank you so much. Okay. So for the gate also,
Like
yeah.
for a exam, we can simply manually calculate or can use calculators, which is best.
See, I consider that if you're having the practiced it, whether it is a good way to solve with the calculator itself, so that you can get the correct answer. Okay, but if you are getting the manually fine answers with a quickly, basically, it's a matter of that how you could solve the problem very quickly. Okay, you get the answer. If you're able to solve it quickly, then it's fine with the calculator itself. Okay. So, and it will be correct most of the time. Getting my point.
Yes.
Okay. Okay.
Is there any negative marks?
Actually, I don't know about this. What is actually the format of this exam? Our job is to only to give the tutorial session so that you can solve the assignments. Okay. If you have any doubt, just mail to them, or if you have the contact numbers and all, you can contact to that coordinator itself. Okay.
Yes.
Okay. Okay. Thank you so much, guys. Okay. Have a good day.